Hi again, Orchidea fam. Welcome back. As promised, we're going to do just a bit more refining of the sound target of the starling. Here's a frequency domain representation of our sound target in the Isotope RX software. It sounds like this. And as promised, I'm going to refine this further based on trying to retain some of the complexity in the chords that you see here where I've got markers placed. So using the Lasso selection tool in a program like Isotope RX or Audio Sculpt or one of these sorts of things, I can isolate these frequency areas that I'm interested in and wind up with a sound file that looks more like this, which just separates elements in the target sound that I may need to orchestrate separately. This is what it sounds like. So by using surface filters or lasso tools or anything like this in a frequency representation, I might be able to orchestrate pieces of the target sound, which allows me to get closer to a more satisfying result in the final orchestration. So what I notice about these particular chords is that they look and sound basically like multiphonics. And there is a nice multiphonic database available to us on the Orchidea website. Okay, here's the Orchidea website. I'm going to go to Datasets. Here's Tiny SOL, Full SOL, and here you'll find Orchidea Multiphonics, and you can download the fingerings and other information here. So here's our patch, basically just as we left it. We don't really have to do much to change what's already going on here. I just want to adapt this very briefly for use with the Multiphonics database. And all we're going to need to do for this is, I think, disconnect the filter styles patch. You don't actually have to disconnect it, but just to show that we're not going to be using this. The main thing is that we're actually going to just need to change the database. So here we have the Orchidea Multiphonics database. And for this, I'm going to use the MFCC database rather than Spectrum, because what I need to do is better approximate the timbre or the spectral envelope of the sound rather than the precise pitches. And even though I'm aiming for a more broad spectrum representation of the sound in this analysis, you'll be surprised at just how well the database will find multiphonics with matching pitches in them. So again, I found that there are just some useful values here through experimentation and trial and error. I'm going to change the onset threshold to 0.5 and the time gate to 1, which is extremely low. Other values may work, but these I've found just give me a satisfying result for today. And finally, because it's a new database, I need a new instrumentation. So let's change this. And just to quickly illustrate this, inside the Multiphonics library, you can see that the sample names are the first element in the file name before the first of the dashes here, and that may differ from the name of the file folder that contains it. To be sure, you want to use this name that's located at the front of the file name, not the name of the subfolder. So the instrumentation that we're going to use for this is as follows. All I'm saying here is that we're looking for multiphonics for flute, oboe, clarinet, and bassoon. Any combination of any multiphonics with relatively little sparsity, any of these instruments that may provide a good match. And the last thing we should do is change the sound file target from the original Starling sample to the one in which we isolated those particular multiphonic-like chords. And here's the result that we got. Now I'm going to start just by playing the target sound once for you. And then together, here is the solution and the target sound. Now I think that's pretty miraculous, that out of the box like that, we get a flute and a clarinet multiphonic that sort of fuse together with many of the same pitches as the original target sound. And of course it retains many of the timbral properties of the spectral envelope of the target sound because we used a database file like the MFCC. Temporally, I think this is a bit of a problem, but why don't we just play with it a little bit here. I'm going to delete this oboe multiphonic because we just don't really need it. I'm going to highlight the two good multiphonics we have, and I'm just going to half their duration or bring them a little bit closer together like so. And then I'm going to highlight and copy, and then simply paste them and kind of move them over to where the second of these markers is, kind of get them approximately in the right place. Let's see what happens if we highlight everything, Command A, and half the duration once more, and then play them together. So I'd say that's pretty close and pretty convincing. It does take the player a little time to start the multiphonic. So when they're perfectly synchronized like this, it takes a little time for those multiphonics to speak, and you as the composer will have to sort of be the judge and decide when in your sequence to notate those things. You can directly copy and paste these things into another sequence like the one we made in the last video, so that you integrate the multiphonic writing with the rest of the orchestration. So the idea here is that we're orchestrating just one element of the larger complex of sounds that are involved in that original sample. This was just a brief example to show you how you can isolate different parts of your target sound, orchestrate them separately to get a much cleaner result, and then perhaps recombine them in your writing at a later time. Thanks for watching, and see you in the next video. Bye-bye.